Okay, so I have a balanced delta source with a positive phase sequence, and I have V12, and I need to determine V23, V31, and then what the equivalent Y configuration is. So the first part is easy because since it is a positive phase sequence, and we know that the phase shift in voltages is plus 120 degrees is going to be the phase shift. So if V12 is 240 cosine 120 pi t minus 20 degrees volts, then V23 is going to be the same as this, but plus 120. So we just change the phase by adding 120. So we get 120 pi t plus 100 degrees volts. And then V31, I add 120 to that, will be 240 cosine 120 pi t plus 220 degrees? Yeah. Okay, so now to change it from delta to Y, so we have delta and we want Y. We know that if I look at like from here to here in my delta, that's 120 degrees. And from here to here in my delta, that's 120 degrees. And from here to here is 120 degrees. And so that's where that angle is in the delta. And then in the Y, each of these angles is 120 degrees. And I know that V delta equals square root of 3 Vy, and this is Vy equals V delta over the square root of 3. And so to get the magnitude for the Y, I take the magnitude for the delta and divide it by the square root of 3. So the magnitude is going to be 240 divided by the square root of 3. Which is 138.6. And the way I remember which one is multiply and which one is divide is by this picture here. And so in this picture that I drew, the delta is the longer one. It's on the outside, and the Y is on the inside. It's the shorter one. And so to get to the Y, I have to divide to get to the shorter value. I'm just telling you how I remember it, not anything about why it is the way it is. So there's that. And then also, if you draw this diagram, this picture, it can help you by knowing that this angle is 30 degrees right here. And so if this, I'm going to draw it again. And so, the phase shift from my y to my delta is 30 degrees. And so all I have to do to get the correct degrees for the y is to add 30 degrees to the angle that I had for the delta, because each of these is 30 degrees. And so the equivalent y is going to be that value that we just got, which was 240 over the square root of 3, 120 pi t plus 10 degrees, because I just add 30 degrees to the angle that I had for the delta. And that is going to be called V1. This one? This is what, let's see, I have this one labeled, so this one is V12. Oh, well, if he has it the other way, then I chose this one because it's the way I labeled it. It goes with this one. This was V1 too, so that's how I had it. But I'll look at how he did it. Like I said, we didn't really do this in Circuits 2, but let me look at his PowerPoint. I thought I downloaded it. So it doesn't really matter which one you label as which. It's just that, like, when you look at if V12, it's just that V1 is V1 is 30 degrees less. This may not be the right answer. Let me see. Let me make sure I have the right answer. So I think that my notes are wrong here and that the delta is 30 degrees more than the y. Is that what y'all have? And so if V12 in the delta is angle -20, then V1 in the y would be angle -50. And let's see if that makes sense with my drawing. Yeah, it does. It does. Yeah. Okay. And then, so then V2 is going to be 240 over the square root of 3 cosine 120 pi t plus 70 degrees. And V3 will be 240 over square root of 3, 120 pi t plus 190 degrees. I am subtracting 30 from the delta to get the y. I was adding, but then I looked at that and it looked like that is what I had in my notes, but I think my notes are wrong because when I look at the PowerPoint, it's showing that if the delta is angle 30 on V12, then the y is angle 0. So the y is 30 degrees less. So to go from y to delta, I'd add 30, and to go from delta to y, I'd subtract 30. And to go from y to delta, I multiply by the square root of 3, and to go from delta to y, I divide by the square root of 3. And I think where I might have messed up is that this is positive phase sequence, and I might have been used to a negative phase sequence, which is different. So, okay. So that would mean, yep. So that's it for that one. So let's do just another one. Mm-hmm. So now I will do number 7 here. All right, so this one is not balanced. Give me a second. I'm gonna recording, so let me go back, and I don't know where I left off. So I'm just gonna say what I already said. So if for some reason you can't use a calculator that does phasors, you have to change it to rectangular, and then change it back. But I just prefer to have a calculator that does phasors. And so we get that. And then to put it in time domain, you have to have the angular frequency, which is 120 pi, because that's 2 pi times the frequency. And then that gets us this.